Hi everyone, here is a new Tesla coil configuration. I have 5 of these that are on these 3-inch high cardboard cores, and that's all 30 gauge wire that's on there. And then this middle one is actually a plastic core of tape that I used, and that's also wound. You don't see it now because it has 3 turns of this copper foil, which is actually insulated between turns. So the backing has insulation and the edges have tape. You can see there the edge. So that actually is a capacitive coupling that goes to my LED, which is now lit. And if I disconnect the capacitive coupling, there you see the LED goes off. I'll light it up again. It's kind of hard to see there with the backgrounds, but it is lit now. And the circuit is out of phase, and well, actually even probably more than 180 degrees. At that point there, it's drawing the smallest amount of current, and this is our current that's being fed to the circuit. So if you look at that, that's the digits here that are important is these ones here, 2466. And now I'll disconnect that LED, and that we're going at 2478. So now the LED is off. It's not on. Like, actually, depending on the angle, it might look like it's on, but no, it truly is off. And now I'll connect it, and now you see that it's on. So there is the current, 2468 with it on, and I pull the connector off there, and we're at 2479. So the same thing. And there is what the scope looks like with it disconnected, and there it is connected. Well, actually, if I bring my hand anywhere close, I'm actually affecting the circuit by moving even my camera around here. So it's very sensitive. So here I bring my hand towards to make the disconnection. I've disconnected it, and now I take my hand away, and there it is sitting stable. And here I bring my hand in again to make that connection. I make the connection, take my hand away, and there it is. So that is the difference. So, and then the whole difference with just pulling the plug on the signal generator. So we're at 2465, and now I just disconnect that, and we're at 2445. So we're not consuming very much from now at this point, because using all these coils I was able to reduce my frequency, and I think the more we reduce the frequency, the better it is. So right now we're operating in the just a little under 900 kilohertz, so less than 1 megahertz, and that makes a big difference. If I could even get it to go down lower, basically there'll be a point where I hook the circuit in, and there won't be any difference between it functioning or not. That's how efficient, I guess, it gets. So there it is, 2446, just sitting doing nothing. And now I connect my connector, 2467, and the LED is lit. There's the circuit functioning. The other change that I did is I have a switch mode power supply here now, which I can adjust the voltage output. That's a 12 volt 6 switch mode power supply, and I've got it so that it maintains my battery perfectly at exactly 13 volts. So even if there's voltage fluctuations in the grid, it stays very stable. And that is my 1 ohm resistor here. The rest of the configuration is the same. And now what I'll do is I will hook up, I have 2 resistors here. Actually I've taken away that 1 ohm resistor. This has been a 10 ohm resistor we've been looking at right now. That's a metal film resistor. And here on the table I have another resistor, and that is a 470 ohm resistor. And I have another one here which is a 1600 ohms. And I will be using that one as well, so that you could see that basically when we put a resistor on the signal generator, forgetting I'm going to disconnect the circuit, you'll see the difference with the meter here, because you know, some might think, well, maybe that's really not showing what the output, what's happening at the output. So I'll just put my camera here because I can't do it with 2 hands. And now I'm going to connect the 470 ohm resistor. Okay, so we have a 470 ohm resistor connected, and that's what what it looks like, the current going through there. And here you can see now all the power is showing on the top because it's a resistive mode and it's consuming power, and all the power is on the top. When you're having power returning, the red display here will be on the bottom, like it is when it's functioning in the circuit. Anyways, let's have a look here at the power. So we're at 2632 and very, very stable, hardly any change. And all I'll do is I'll disconnect the output. So 2632, and there it is. That is the signal generator just working on its own. 2668. And now reconnecting it, the load, and we're back at 2632. So that is the difference with that 470 ohm resistor. And now we're going to go much more sensitive. I'll put that 1600 ohm resistor on there, and we can detect that. I've tested it, and I've actually tested up to 4.7K, 4,700 ohms, and it was able to see a difference with that as well. So that now is connected, and that is what the power use was happening with it. So obviously it's not consuming as much current, you can see, but current and voltage are in phase and obviously consuming power. And if we look here at top, we have 2520, very, very stable there, and I will disconnect that from the signal generator, and we have a 2467. So there you go. That is the update, and thanks for watching. Bye now.